and then we can start doing KCL. All right. So we want to sum up currents at a node. All right. So let's say we're going to do KCL at node A. So I usually write on the left side, maybe off to the edge in the margin, or just wherever I'm going to start writing the equation. Right, what am I doing, KCL, and where am I doing it at node A? So when I go to node A, I've got I1 labeled, and I've got this 20 milliamps labeled, but I need something for this resistor here. So at this point, we just have to pick something. We have to pick, is it going to the left or the right? And either way is fine. We're going to use that arrow to decide whether it goes, which side of the equal sign it goes on, or whether it's adding or subtracting. But our answer is going to match with that arrow. Okay? So it's part of that sign convention where we're agreeing about how we're going to label things. All right. So how about, would you like to pick left or right? Which way do you want the arrow to go? Left. All right. So now it's entering node A. And if we want to put it into an equation, it needs a name. Since this one's I1, we'll call that one I2. So then we can write KCL there. We've got 20 milliamps entering and I2 entering. So 20 milliamps plus I2, that's on the entering side. And then the one that's leaving, I1, we would subtract. And that's going to make it equal to 0. What's entering has to equal what's leaving. So we subtract the leaving, and it should come out to 0. So I have entering. Oh, do I need to scoot? Entering, entering, leaving. All right, well, I have one equation with two unknowns, so I need to keep going. So let's look at node B. I've got I2 leaving and 6 milliamps leaving. And then up here at the top, do I know anything about this branch? Right. If we take this 4 milliamp piece of information and we work our way backwards through this branch, we would look at it and say, is this 4 milliamps going through this entire branch? Or was there anywhere else it could have split off, any other nodes where it could have gone away and split up? So if I back up to node B and I say, well, if this is 4 milliamps, it's going to go to this corner, and it only has one place to go. It's going to go down, and it's going to go to this corner, and it only has one place to go, so it's the same 4 milliamps. Okay? So if I want, I could redraw this 4 milliamps going to the right so that by the time it makes two turns, it's going left. Right? Two wrongs don't make a right, but three lefts do. Think about that. If you're stuck on one-way streets. So we know the 4 milliamps, the 6 milliamps, and the I2. So we can write KCL at node B. I don't have anything entering, so they're all leaving. So I would have minus I2, minus 6 milliamps, minus 4 milliamps equals 0, because they're all leaving. And that only has one unknown. So what can I figure out about I2? Okay. Negative 10 milliamps. That's fine. So if I know that, I can go back to my first equation and figure out I1. So I have 20 minus 10, because that's negative, minus I1 equals 0. So I get I1 is equal to 10 milliamps. All right, so there I've answered the question. I could double check by doing KCL now at node C. I would have I1 entering, 20 milliamps leaving, 6 milliamps entering, and 4 milliamps entering. So I would have 10 minus 20 plus 6 plus 4 equals 0. Did I do it? Yep. So yes, that's true. So that's my double check.